Hello students, I am Rohit Mehta. Welcome to ATP STEM. Many students who are preparing for timed examinations like JEE and NEET tend to find the two-block problem daunting. Are you struggling too? In this video, we will take some specific types of two-block problem where I'll tell you the standard way of solving the question first, and from that method itself, we will try to create a simple trick that can be applied for some specific type of problems. Those problems where force is acting on the lower block, this trick will every time give you the right answer. So let us take a question to understand the standard method. Question is, we have to find the maximum force for which both the blocks will move together. In this case, you can see force is acting on the lower block. Now, in order to move the upper block, which force is responsible? Yes, friction force will be responsible to move the 5 kg block. In this case, how can we find the value of friction? By the formula mu times n. So if you put the value of mu and n, you can see that n will be equal to mg. Here mass is 5, so we can write 0.2 times 5 into 10. And we are getting 10 Newton. Now this 10 Newton we can directly get if you directly multiply this 2 with this 5. So here if the value of mu is given as 0.2, 0.3, 0.4, 0.5 like that, then you can directly take the number from here, multiply it with the mass. You can say that will be the limiting friction that will act on the upper block. Now, next what we can see is, in order to find the acceleration of the 5 kg block, we need to divide the force with the mass. Force is mu mg. If you divide it with the mass, you will be getting the value as mu g. Now, if you see here, mu if you multiply with g, which is 10, you will get the number itself. Here you will get 2. So can I say that the acceleration of 5 kg block will be just this number that is written over here? That is the most important part of the question. Because if you identify that very quickly, you can solve the question without even solving this part. Easily you will get the answer. So here you can see 2 is the acceleration for the 5 kg block. Once you get the maximum acceleration for the system for which both the blocks will move together, then you can assume both the masses to be a single mass. Here I can say these two masses can be replaced by a single mass of 15 kg. If both masses move together, acceleration is 2. We can say the net force required to move the masses together will be equal to mass times acceleration, that is 15 times 2. That is giving us 30 Newton. So 30 Newton is the maximum force for which both blocks will move together. So here, if you can understand this trick, you can solve the question very easily. What is the trick? From the mu value, you just take the value of 2. That will be the acceleration of the system, and then directly multiply it with the mass of the system. You get the net force. So let us try to apply the similar trick within other questions. So let me show you another problem. In this question, you can see we have 8 kg block resting over 4 kg block kept on a surface which is smooth, and the force is acting on the lower block. Now, again they are asking us to find the maximum force for which both the blocks will move together. So those type of problem where force acts on the lower block, our trick will work. Here you can see that to get the maximum acceleration, I can directly take the value of mu. Like here you can take 2 directly. That will be the acceleration for the system. And once you have the acceleration, multiply it with the combined mass of the system, you get the force. So here force will be 24 Newton. So now let us try to apply the same trick with another question. Here you can see that we are applying force on the lower block. So yes, this trick will work here as well. So we have to find the maximum force for which both the blocks will move together. But here if you observe, I have given you some coefficient of friction for the ground surface. That means this time there is extra friction force that is acting from the bottom. Initially in the previous cases, the surface was smooth. So here you can see there will be an extra friction force that will act on the lower block. So approach will be similar, but what will change? Let us understand this. You can see here for 5 kg and 10 kg block, we can say in between there is a coefficient of friction 0.2. That simply means 2 will be the acceleration for the 5 kg block. Once you get the acceleration for a 5 kg block, you can say, sir, this will be the maximum acceleration with which the system will move together. So in this case, you can see that the kinetic friction that will act between the bottom surface and 10 kg block, that we can figure out by the formula mu into n. This time normal reaction will be the combined mass into g, that will be 15 times g, you will be getting 15 Newton. This 15 Newton which is acting in the backward direction, we can show over here. You can see that the maximum acceleration for the system is 2 meter per second square. There is a force acting in the forward direction and a force which will be acting in the backward direction. This time the net force is not F, it will be F minus Fk. Let us put that value. So when you put F minus Fk, that is the net force equal to mass times acceleration. You can easily find out the maximum value of force that is applied on the system for which both the masses will move together. Now let us try to solve this question by applying the trick. You can see here, we know that coefficient of friction is 0.2, so we can easily say that the acceleration will be 2 meter per second square, directly taking the value from here. And once we know the acceleration, we can directly say net force equal to mass times acceleration. From there you can easily figure out the value of force. So I hope you are getting clarity about this trick, how to apply this properly. Now there is one more question that we have to look at. In this question you have to apply the same trick and directly get the answer. So pause this video, try to do this question by yourself and see if you are getting the right answer. So in this question you can see that both the blocks, if I have to figure out the maximum acceleration, I'll directly take this value which is 2. After that, I know there is a forward force and there will be a kinetic friction that will act on the lower block. So the net force will be F minus small f. And this net force is responsible to accelerate the system. So we can say that is equal to mass times acceleration. 12 into 2 will give you 24. You get the value of F as 36 newtons. So I hope you like this video. So do not forget to like this video and subscribe to this channel for such amazing tips and tricks related to physics and other subjects.